In 2017, the benefits of a reliable supply of high-quality water for stock were outlined in a Ministry for Primary Industries report. But for many remote farms or hard-to-reach locations, water reticulation systems are limited by their access to power. Now the use of solar panels to power pumps and other machinery for delivering water is proving a viable option for farmers in a variety of situations.
This is a 113-metre portable pivot. The water pressure comes from the scheme and delivered to the gate. The solar is powering the pivot itself, the wheels, turning it around. It's operated on 3 sites. There's 3 hectare sites, and the machines move with a tractor end towed between the sites. It's an effective way of delivering a small amount of water over the 9 hectare irrigated area. We're growing peas for seed here. About 4 litres a second comes out of this machine, and it's probably the most effective solution we've got for delivering that small amount of water over this area. Well, this probably potentially could double the yield on this crop here this year. This is our second season operating this. The pivot was constructed by the manufacturers, Pierce, and then a local company, Frizzell's, put the solar system on, and we hit the button on the first day, and it's gone ever since. Really pleased. It was, I think, $11,000 cost up front to install the solar here, but there's no sort of ongoing annual costs every year. I'm sure that at the end of the lifespan of the batteries there'll be a replacement cost, but hopefully we're a wee way away from that. The three main big pivots.
The key thing with corner irrigation is that often you've got water to areas but you don't actually have electricity there. So to get power in can be quite cost prohibitive. So it means that what they can do is they can then utilise the area much more efficiently by being able to apply water to it, and they don't have the high running costs and installation costs of electricity. So you just hook it on with the tractor 3-point linkage?
We do, yeah.
From the initial design stage, we need to know the location, so then we can get the data for that location in terms of the radiance figures, so the energy from the sun. And then from that, when we know how much they're running the machine, then we can actually design the system to suit that individual situation. In terms of the solar panels, it's actually designed to be universal between different manufacturers. So basically the same as a generator, that you just got your 3-phase plug with the big machines that you just plug in. And then it means then if there's any issues, like for example, if an animal broke in and managed to damage lines and stuff like that, then you can literally just unplug the solar setup, plug in a generator, and you're up and going again. It also just means then that, we can guarantee that you're actually getting good application too, because water application for farmers is crucial and you don't want to have downtime. So that's why we've made sure there's a lot of fail-safes and things like that in the systems. The panels are designed for up to about 215 km/h winds, I think it is. In terms of the irrigator itself, we've done work with Callaghan Innovation, which is the government research and development arm. And in terms of that, it actually increases the stability of the pivots, so they're actually safer with the solar panels on than they are without them. With solid charge controllers and things like that, we're up to about 98% efficiency or so. With time, the price is reducing a little bit per watt. The solar panels are getting slightly more efficient as time goes on, but that's sort of a gradual evolution rather than a dramatic change in the last few years. The batteries should last about 10 years on this irrigator, so that's only about, on today's prices, about $3,000 or so every 10 years in terms of replacement cost. Compared to the price of power, is substantially more economic. This system is a stock water system. So as opposed to the irrigators are designed to run 24 hours a day, so they have batteries and things like that involved in the system. This one, just to keep it the most reliable and simple package, is solar panels going straight to the pump, and then that just runs during daylight hours, and that pumps from the spring down the bottom, so it's lifting up about 240 metres vertical, plus about 1.5–2 kilometres in distance to the storage tanks here. And then so what that means is the storage tanks supply water to the troughs, so when the animals are drinking it in the evening, and then during the daytime the pump pumps fast and what the water's going out, so they can then fill the tanks up, so they've got a reservoir here to keep it going 24 hours a day. It's about a 10 kilowatt pump. There's about 15 kilowatts worth of panels. So we put in a larger array than what the pump requires, so that then hopefully in overcast conditions and stuff, you're still getting enough energy to drive the pump.
We are 12,000 stock units, sheep and beef breeding and finishing. So all the breeding's on this hill country property, which is 1,400 hectares just to the east of Cheviot. We needed to get a better water system. All of these properties have county scheme water, which was put in the 60s. We started looking at the price of mains power to get to the source of water, but it was just going to be too much. We really had to look at alternatives. I wasn't really sure whether it was possible because we're talking quite a big lift and quite a volume of water. But after talking to Nick, they said that they could do that, so that's the way we went. It lets you manage your pasture a lot better by being able to use mobs of stock where you want them, when you want them. So therefore, a lot better pasture control, a lot better pasture quality. The stock prefer to drink out of a clean trough than a muddy dam or a creek anytime. So environmentally, it's a good outcome as well.
Thanks, New Zealand On Air.